Go ahead and attempt to solve a bond pricing problem. What I'm going to recommend that you do is pause the video and read this problem twice, and when you come back, I'm going to go ahead and highlight some of the key parts of it that we're going to need to use. So whenever I do problems like these, I'm always looking for the numerical values that I'm going to use in Excel. So for example, I see that there's $50 million in total book value of bonds, and that each bond has a $1,000 par value and a 4.75 coupon paid in June and in December. What that tells me then is those bond payments then are semi-annual in their nature. Their credit rating is A, and prices for similar risky bonds are 4.55%, and we're in January of 2016. The bonds mature in December 2025, and were originally issued in January of 2000. So the second thing I like to do is then document my assumptions, and that's just a fancy way of saying to type down into Excel everything that we know about the problem, especially those things that will be used in calculations. So we start off by knowing that there was a book value of bonds of $50 million. And that each bond had a par value of 1,000, and that it had a coupon rate of 0.475. And I'm going to notate that that was semi-annual payments. Whenever we see a rate that is naked, like 4.75, then we can assume annual. But when it's qualified like that, semi-annually, means we're going to have to make an adjustment. Yields to maturity for similar bonds are 0.0455%. Again, that one's naked, so we're going to have to deal with it in terms of it being annual and getting it to the semi-annual period so that it matches that bond. So here we are, and today is January 1st of 2016. The bonds look like they have a maturity that will be on 12/31 of 2025. Let's make these formats the same. And then it looks like they were originally issued in 2000. So, although we don't seem to agree on its value, I am still a big fan of drawing out how these bonds work. So let's take a look at how we might sketch out a bond. What we're thinking about here then, and I like to think in terms of a timeline, was originally what happened was these bonds back in 2000 were issued. Then time has passed until we are now here on 1/1 of 16, and that is today, which is the present, so we call that period 0 often. And then the next thing we worry about is that we have until December 2025, which then will be the maturity of these bonds. So now that I have that particular layout in mind, I can go ahead and take an even deeper look at what's going on today by sketching this thing out like an investment. So if we are here today at period 0, which is 1/1/16, here's what I'm thinking about as an investor, is that I'd be willing to spend some money, meaning buy a financial instrument like a bond for a certain price. And if I did, then I would have the reasonable expectation that I would get things back over time. Specifically, the reason that you buy things and get outflows in the present is because you're looking for the opportunity to get inflows later on. So what are the inflows that you're going to get with this particular bond? Well, according to this, in June of 2016, you would get your first coupon payment. And then in December of 2016, you would get your next coupon payment. And then in June of 2017, you would get your next coupon payment. And that continues on all the way through the end of your holding period as a bondholder, because that bond will eventually mature. And that maturity, we said, would be in 12/31 25. And here is where there is no shame in doing finance on your fingers. If we have then 2 payments for the bond that come in the first year, that's 2 semi-annual periods. We then would have a total of 20 semi-annual periods, as that bond paid twice every year, each and every year, from 2016 through 2025. But additionally, what happens in 2025 is we would have the par value that we would get, or the original amount of that bond loan or face that we would also receive. Now, what do those cash flows actually look like? Well, we know that bonds have $1,000 par values. So now let's go ahead and treat this coupon payment. We said a couple of times that coupon payment is equal to the coupon rate multiplied by the par value. But then we have to divide those by the number of payments per year. So in this particular case then, we can easily start going into Excel now that we've drawn this thing out. And in the next step of this problem, after we've drawn everything out, what we would like to do is start to use Excel to solve the problem. So we're going to now use Excel. Okay, so what we come back to then is our basic variables over time, which we can then use our translator to figure out what they equal now. So we always use present value. For bonds, that's going to be called price. We always have future value. For bonds, that's called the par. We always have a payment. For bonds, that's going to be called coupon payment. Then we are going to have a rate, which for bonds is called yield to maturity. And then we're going to have a time, which for bonds is called the maturity. So now, referring to the information that we typed up above, we are trying to solve for the present value or price in this particular problem. So let's go ahead and highlight that yellow. Oops, we missed. Let's go ahead and highlight the proper box, yellow. And we'll take off the highlighting there. Okay, when we have then a par value that is going to be equal to the $1,000 that we notated previously, then we need to get this coupon payment. So watch carefully. The coupon payment then is going to be equal to the coupon rate. Oops, we're going to hit that again. Is equal to the coupon rate of 4.75% multiplied then by the par value, which is that $1,000. I'm hitting the wrong button here. There you go. Hit the wrong button again. Let's show you this. That's the coupon payment multiplied by the par value. And then, because it's paid twice, we need to take that whole thing and divide it by 2 so that we get a $23.75 payment would be made twice per year. How often is that thing paying then? At twice per year for 10 years, that's 20 periods. And now the rate we had keyed in before was up top at the 4.55%, but that was annual. So in order to be able to get it to be properly aligned, we're going to have to put it in as semi-annual, or twice a year, so that when we look at these 3 variables then in here, our payment, our rate, and our yield to maturity then are all based in semi-annual periods. So now let's go ahead and we'll drop in our present value formula, where the rate, which is semi-annual, for 20 semi-annual periods, where you're getting a semi-annual amount of, and eventually you get $1,000 face value tells us that the price of this bond should be $1,015.93. After we've done all that, now we can figure out, well, what does that mean? What that means is that an investor right now should be willing to pay up to $10,015.93 in order to purchase